Problem 53, we're going to review how you prove uniqueness results for element satisfying properties. And the property could be, well, in this case, the property of being a unit or a unity. So u times anything is whatever you're multiplying by. It could be the uniqueness of inverses, additive or multiplicative. It could be the uniqueness of the zero element as well. All of those arguments are similar, and they all start by assuming the same thing. Suppose there exist two complex numbers. Say there's the complex number 1, but this is sort of 1, 1, and another complex number 1, 2, where we should think about them as not the number 1, but as a complex number that when I multiply it with anything, I get that thing back. So I'll write that down. So there exists a 1, 1 and a 1, 2, such that 1, 1 times z is z times 1, 1 is z for all z and c. And the same thing for 1, 2. So they all sort of behave like the number 1, or they both behave like the number 1. What we want to show is that, well, this cannot happen. There's only the number 1 that behaves this way. And the first step is to, of course, assume that there's 2. And then second, we're going to use the defining property namely this guy up here, to show they must be equal. Okay, so let's carry that out. We know, but let's call this maybe star and this one x. By star, we know that 1, 1 times 1, 2 is 1, 2. Using z equals 1, 2. And by x, we know by looking at the middle ones, 1, 1 times 1, 2 is 1, 1. Using z is 1, 1. Sorry, that's a lot of 1s and 2s being floated around. So for star, we're using this part of the equation. And then for x, we're using this part. The left-hand terms are the same. So 1, 2 for our first guy is 1, 1 times 1, 2. And then for the second guy, 1, 1 times 1, 2 is also equal to 1. So it must be that our two different units were the same thing. Now this is a bit silly over the complex numbers because of course only 1 is the guy that works. Nevertheless, it's important to prove these basic properties. And when you encounter more complicated algebraic structures, it's not so obvious. So being able to have a generic proof or a generic proof style that works for all algebraic structures is important because you can copy and paste it over and you can reuse the proof strategy. So what did we do? We said suppose there's 2 of them and we learned that they had to be the same. So that must mean our unit is unique. Let's make this step 3 the conclusion step. We conclude that the unity in C is unique. Furthermore, we know that the complex number 1 plus 0i is a unity, and since we just showed there's only 1, it must be the unity. Okay, so 1 plus 0i, of course, we think about as the number 1.